Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're talking about the second form of exponential, how to differentiate it, okay? Please don't forget to like, share, and subscribe. And if you've not clicked the notification bell, I don't know what you're waiting for, so that you'll be the first person to know when I upload new videos. So in the previous video, the first form, we talked about how do we integrate something like e raised to power x, or you have something like e raised to power kx, or you have e raised to power a function of x. So we talked about the first form in the previous video, okay? Now, in this video now, we want to talk about the second form, which is a raised to power x. How do you differentiate this one, all right? So in this case, a is a constant, all right? So if you have this kind of exponential, so for example, you are given y is equal to 5 raised to power x, for instance, and you are told to differentiate this, okay, or any other form of this kind of integration, what do you do? Now, what you do is very simple. You only have one rule. When you're having this, you only have one rule, and the one rule is you multiply the ln of the constant with the original question. That's it. So what you do to get it to differentiate, you have to multiply the ln you have to multiply the ln of the constant with the original question. That's it. That's the only thing you have to do. So that means in that example where we have y is equal to a raised to power x, okay? Now the derivative of that will be equal to the ln of the constant, so the ln of a, which is the constant, multiplied by the what? Original questions, and that will be the answer for that. That's how to do it. So when you have this type of exponents, it's very easy. It's going to be the ln of the constant multiplied by the original question. So let's go. So let's assume we have, I'll pick some example for you to, let's try together. So if we have, for instance, y is equal to 5 raised to power x, okay? The derivative of that is going to be the ln of the constant, which is going to be ln 5, multiplied by what? 5 raised to power x. And that will give us 5 raised to power x ln 5. Okay? Let's pick another one. So let's say we have y is equal to 3x, the same thing. The y over the x is going to be the ln of the constant multiplied by 3 raised to power x. And that will now give you 3 raised to power x ln what? 3. And that will be the answer for that. Okay? If you want to pick more, let's say we have y is equal to 4 raised to power x. The y over the x become the ln of 4 multiplied by the what? The original question. And that will now give you 4 raised to power x ln 4. Easy. I'll pick one more so you can see it's almost repetitive. If we have y is equal to 20 raised to power x, okay? The same thing. The y over the x will be equal to the ln of 20 multiplied by the original what? Question, 20 raised to power x. And that will give you 20 raised to power x ln 20. And that will be the answer for that. All right. So I want you to try this once yourself. Okay. So if you have y is equal to 8 raised to power x, you have y is equal to 6 raised to power x, you have y is equal to 7 raised to power x, you have y is equal to 10 raised to power x. And I want you to now find the first derivative, the dy over dx for this. Okay, so you can put your answer in the comment section, you can discuss with a friend, or if you are not really sure, you can send me an email or you can see me and I will try as much as possible to respond to you. Okay, that is that for that. So that is that for the second form of exponents. Okay, how do you differentiate it? So basically, you just take the ln of the constant and you multiply it by the original question. Now, the next rule I'm going to talk about is how do you differentiate natural logarithm or the lns, okay? How do you differentiate ln? So for instance, when you have y is equal to ln 5x or something, and they ask you to differentiate that, how do you do it? All right, that's what I'm going to talk about in the next video. And so don't forget to click the notification bell. So when I post the next video, you'll be the first person to know. All right. So I'll see you soon and have a nice day.